Hello everyone, I'm Xiao Gang. Okay, we've set up the basic framework and then I took a look. Let's execute it once more, and this time we'll add this thing in. In GFrameCounter, we'll bring it in and record the frame count of its execution, which is actually here. Okay, this thing here is similar to a UENT64. It's in this Callable's location. Obviously, it's inside Mesco with some clutter. You can see here that it's some global ones. Yeah, variables like these. And then in other words, these variables can help you to get some things. This way, you can know what kind of situation it's in now. You can see these variables are all very useful. And now what we need to use is to take this UINT to receive it. I'll mark all these things. Actually, we could use a time, but we're not really using this time approach here. Because of the time, we need to convert it to seconds. It's actually a bit annoying. We mainly want to check the frame rate. Okay, here we give a farm index. This is mainly for everyone, because we are still in the multi-threaded layer, mainly to reinforce for everyone. Reinforce this concept about games, because it is indeed different from our traditional development. It particularly emphasizes this real-time rendering pipeline. That is, one frame must be rendered within about 10 to 30 milliseconds. If it's not rendered, then this thing won't work. It's unplayable. This is also the power of real-time rendering. Okay, then here, let's move it over. Move it here. Here, we write it like this. This method means we don't need to reflect. We just paste it here. Let's copy this over here. Okay, then here we change this here. Copy this over here again. Okay, then here we can see. Here, okay. Then let's move this over here. Now we can run it and let everyone observe the result. Then the main content of this lesson is adding two delegates to allow our blueprint to receive interactions. Then we will simulate for everyone below how to do these daily step processes inside. I found that there is indeed an awkward thing. We haven't taught you about networking yet, haven't taught you about saving, and haven't even taught you about image, PNG and JPG serialization and deserialization. As a result, there are many things we cannot dive into here. Okay, then what do we need to do now? Then this control flow here, we just execute it. We execute I1, and you can see, you will find that we are all executing on this 10.77G. That obviously doesn't quite meet our expectations, right? Okay, we'll optimize it for you later. Let's expand on this process. Here, the lesson mainly involves writing two delegates. Let's first bring this delegate over. It's relatively simple. These are two dynamic multicast delegates. The first delegate is a parameterized one. This is a progress update. Next, we'll handle the progress update. My input method here is stuck. Hey, that's strange. Hold on a moment. Okay, this part is the progress update, and here is the initialization result. For comparison, if it were me personally, I like to add one more parameter. It indicates which update it is. Since this is the case, let's add it for everyone anyway. This concept is very important. So here, we will introduce this concept to everyone, because this concept is, during our development, sometimes in order to troubleshoot errors, we will add such a behavior. Only then can we locate exactly which update went wrong. Obviously, this place should be placed here. As for this parameter of ours, we will call it FQID. We could use factual. but I prefer using GUI because it is a struct. It looks nicer. Then a comma called init id async. Right, init exit. Then this SAM1, we paste it over. All right, put it here. Okay, so this is one with 2 parameters. This is one with 3 parameters. This is a dynamic multi-wave proxy. Then we can actually put it in this position. We can pass it in. We can also let it do the binding separately. So obviously at this point, it's more suitable for us to let it do the binding separately. That way we don't need to, because it's dynamic multi-wave, we don't need to go anymore. Usually we add an XG. To avoid adding a hand from simple, control, close. Okay, then we start declaring it here. We call it initPogs. This part is uProperty. Then here, we use this Blueprint assemble. This exposes it to Blueprint. It can be bound. Okay. Here. In this place, we need to use the result of this speed optimization. We call it init result. Okay, good. This way we can bind it. And similarly, we might, sometimes for convenience, we can directly call it here. That's also fine. Let me think about it. We can actually add a float here. Let's add a progress. Let's give the float a value, say 0.1. Okay, let's give it 0.2. Here, we'll just write 0.30.4. Casually here, let's give it 0.8 here. Give it 0.5 here. This one is 1 point. Okay, after making this change, we also need to change the function name here. This is the idea of this kind of payload. Otherwise, let's just add it. If we don't change it like this, it should cause a compilation error because it doesn't match. Okay, after we do this, we can get our progress here. The progress passed earlier. This will throw an error. Let's take a look. Let's check which part is causing the issue. I found the cause. Found that you cannot use float. You're using double now too. The reason is actually very simple. Why could Flutter be used before? Now using double. It's because they need to make this open world. Flutter's precision is clearly insufficient. So that is a double conversion. And actually when you write this function, we see this function signature. You can also tell it clearly supports variable parameters. We mainly look at the signature. You'll see the first one is our debugglem. The second is this object. You see it's the object. Then here is the variable parameter. Actually, let me check when the problem occurred earlier. I could still see it. Let's change it to a float. You can see this issue. Let me explain how to troubleshoot it. Because Unreal Engine updates frequently, if you haven't mastered this troubleshooting technique, it will be very painful. Especially when you upgrade the version. You can see, we caught this function reporting an error. And here you can see, it clearly supports this variable parameter, including this. This function signature here, it also clearly supports. We can see here, look at this editable meal. So it can be used in this form of recalibration. Then observe the log here. You will find there is a wall here, double, double. You see flux, double, and then 5 point. You will immediately realize it has progressed. So we use double here. Okay, we compile here, then there should be no problem at all. You see, and here, actually, you can notice, actually these can be completely swapped. You can absolutely do it this way, like this. For example, if you think this should be done first, then you just do it here. No problem at all. Now that we have 2 agents, as for how to call these 2 agents, actually, I personally prefer to write a method to call them. I personally prefer to create a staggered execution method. You might have often seen this before. That is, when we log, we do staggered execution like this. But I think here, it doesn't seem necessary to do staggered execution. That's quite obvious. If we execute this, every time we execute it, right here, we'll just broadcast the progress. We take this progress, and then here we give it a broadcast. Let's broadcast this. Okay, and then here, we need a GUID. So the GUID, actually, we need to generate it here, right here, GUID. We'll leave 1. Okay, then our ID changes every time we generate. So we need to put this ID here. Init sync. Okay, we can leave this empty. Okay, then we roughen it here. When execution is complete, we can set it to empty. This actually extracts a 4-bar support from Anki. We will have some standard commercial tutorials later. We will extract them for everyone. Extract a 4-bar support function interface here. Okay, after this execution is complete, what do we need to do? Take a look here. Then we can actually place these 3 IDs here. Okay. This way we can receive this progress. Good. Actually, if we test it now, we won't be able to see any effect at all, because all these tasks are completed in a single frame. In fact, on the last frame, it will trigger this multiple times. Then in this frame, the final result will actually only be 1.0. Let's still write it out for everyone. Let's first set up the framework. Okay. Obviously, at this point, it might be the best time to have a UI. Let's create a UI here. We'll give it a and call it country flow. Manually. Okay. Then here, actually, I haven't explained the UI yet. UI can also be written in C++. You just do the binding here and write all the logic here in C++. Write the C++ on the parent class. Then kernels. Let's give him a boarding. Also a canvas. Let's center this canvas. Then let's reset this quantity. Then give this a 0.5. Let it be right in the center. As for this size, we'll give it a size box. And actually for the size box, if we give it an override, we'll give it 600. Then here, let's set it to scale to content. Within the size box, we can actually give it this color. Let's make it gray. That way it looks better. Then think about it. We could give it a progress bar or a float number. Let's give it a float number. For this, we need to give it an overline. This way it's easier for us to place it. Okay, then we give it this, and place it in the center. Okay. Then we need to adjust our box so it's not this tall. Move this position up a bit. We can adjust this by changing the transform. Giving it 500 is too much. 吃200，这里100. This is our progress, right? Then we'll have this progress displayed here in real time. Let's give this variable a. Actually, we can just give it a progress. Now, that's fine too. For convenience, I'll give it a progress value. Then here, let's set the progress to 0 first. Yes, to avoid any issues with this number. Okay, then here, we'll bind it during its construction. We get xt, found, event to progress. Then here, there should be two functions, found, event to rig out. Similarly, we bound it. So a good habit is you must unbind it. Here we take it from here again. It can also be done when subscribing. We call it unbound from progress. Unbound from result. Align it like this. Okay, then here we create a world dispatcher. Here we directly create a world dispatcher. Then this function, we let it create a matching function by itself. Here as well, we create a world dispatcher. Then create a matching function, and here, when subscribing, perform the unbinding. Okay, so for this function, the first function is obviously for this progress. We'll just give it an update progress. Here, we just need to give an init result. Then, when we succeed, we don't have this practice succeeding right now, right? For this ID, let's just print a log. We'll concatenate a string like this. These are all common methods for UI debugging. We'll give an ID. Okay, we'll just log the data ourselves here. Here, result. Okay, and here, message. We'll also give a message because there might be some reason for failure or something. Okay. Yeah, there will be no problem after doing this. Then let's paste this. For progress, we also log it. Then this place. We just need to change this place to progress. Pro plus ESS. The reason this place is not merged together is because sometimes our requirements are different. So you need to split it apart. That is, some people might want to record individually the status of these progresses. Okay, then here we give a quest stream and print it. Then here we make a simple branch result. If this place, we directly push it. If it succeeds, then trigger success. We directly set visible. We hide it. Take a look. Always should be. Right, the visibility of these facilities. Hide itself. And if it fails, I make it show this button. Then we add another button here. Just put it here. Add a txt inside this button. I give it importance. Okay. Then we move it down. This looks a bit ugly, but forget it. We initialize it. So we give it a, this is not needed, this is needed. We should call it init button. Okay, here it is. Our world is not over yet. So if it succeeds, if it fails, if it fails, we set the progress to 0. Up-to-date progress. So right here, set the text for this. We just set it to 0.00. The update progress here, after we win the battle. Actually, we set it to text here. If we want to convert this float to txt here, we demonstrated this to you earlier. Here, we just change all the decimal places to 2. This ensures it is normal. If successful, we hide it. We can now check the result. Then when you click, we definitely need to execute initialization. There are still some logic details to improve here. For example, you cannot allow repeated clicks. Although we know here, if it is clicked repeatedly, just log a message like this. It has no effect. But sometimes you also need to provide some more complete interactions. But you must separate the actual logic from the logic you present. If you don't separate them, writing them together will be very painful. Okay, we won't go into that here. When we begin play, create wicket. Then here it is obvious that it is our VVB country flow, and then we directly add it here. Call port. Obviously, we need our this mouse's gate player controller. Write it like this. There is no problem now. If you are developing an online game, there will be a problem, because in fact, this issue lies in the fact that there is no player control on the dedicated server. That is, when the server first initializes, when no player has logged in yet. Everyone knows this. Okay, we initialize this point, and there is absolutely no problem, right? You can see that we are still executing in 1 frame. There's still a little time left for these. Then, count. I feel it's a bit long. Then now we have something like this, a blueprint interaction logic like this. The reason we didn't receive success on this one is actually very simple. You can see, because we don't have a proxy here, right? We'll refine it in the next lesson. This lesson ends here. Thank you, everyone.